Say, walk to your dog right now, and it'll probably lose its mind. Say, the neurologist confirmed the diagnosis in the exact same happy voice, and it might lose its mind too. So does your dog actually understand the word walk, or is it just responding to how you sound? Here's the real number. From an actual peer-reviewed study of real dog owners, the average dog responds consistently to about 89 words and phrases. Not a made-up round number, 89. Now here's the number that breaks the curve completely. One dog, a Border Collie named Chaser, learned the names of 1,022 different objects, and scientists ran out of time before she ran out of room to learn more. Those two numbers can't both be describing the same thing your dog is doing on your couch right now unless you understand what's actually happening inside a dog's brain when it hears a word. Over the next 20-some minutes, I'm going to show you the real research behind both of those numbers, the specific brain mechanism that makes words work at all for a dog, and exactly why almost every list video you've seen about words your dog understands is quietly getting the science wrong. This is PetMindLabs. Let's stop guessing and start seeing. Let's start with the assumption almost every dog vocabulary video quietly makes, that when your dog responds to a word, it's because your dog knows what the word means, the way you know what the word chair means. That assumption feels obvious. It's also not quite right, and the gap between responds correctly and understands meaning is exactly where the interesting science lives. Try this thought experiment. Your dog sits when you say sit. Is that because your dog has stored a dictionary entry sit, verb, to lower the body onto the haunches and retrieves it when it hears the sound? Or is it because, over hundreds of repetitions, the specific sound pattern sit got wired to a specific muscle action, because that muscle action reliably produced a treat, a click, or your approval? Those are two completely different things happening in a brain, and from the outside, they look identical. Your dog sits either way. This isn't a small philosophical detail, it's the entire question this video is built around. Because right now, all over the internet, there's a wave of videos with titles like 7 words your dog actually understands, proven by experts, 9 words your dog actually understands, 10 words your dog actually understands. I watched a stack of them preparing this. They're pleasant. They're not wrong, exactly, but almost none of them name a university, a year, or a sample size. They say, proven by experts, and then just list words. Treat, walk, no, good boy, that's it. No mechanism, no number you could actually check. So here's what we're going to do differently. We're going to give you the actual number from an actual peer-reviewed study with an actual sample size you can verify. We're going to show you what a dog's brain is doing literally on a brain scanner when it processes a word versus how that word is said. And we're going to look at the one dog who learned over 1,000 words. Not to tell you a cute story, but to figure out exactly where the ceiling really is and why almost no dog gets anywhere close to it. Because the honest answer to how many words does my dog understand isn't a single number at all. It's a range, a mechanism, and a boundary. And by the end of this, you'll know how to test where your own dog actually falls on it. Let's nail down the baseline first, because most of the internet has this one wrong. You'll often hear that dogs understand around 165 words. That figure gets repeated constantly, in articles, in videos, sometimes with a straight face, like it's a scientific consensus. Here's where that number actually comes from. A popular book called The Intelligence of Dogs, written by psychologist Stanley Coren. It's a fine book, and Coren is a real researcher, but that specific number wasn't published in a peer-reviewed journal. It came from surveying about 200 professional obedience judges about how many repetitions it took different breeds to learn a new command, and how reliably they obeyed on the first try. That's a study of trainability, how fast a dog picks up commands dressed up and repeated online as if it were a study of vocabulary size. Those are not the same measurement, and the 165 figure has been photocopied across the internet so many times that almost nobody traces it back anymore. So what does an actual vocabulary study look like? In 2022, researchers Reeve and Reeve Jacques at Dalhousie University in Canada published a study in the journal Applied Animal Behaviour Science with a much more direct method. They surveyed 165 dog owners' different sample. Don't get confused by the coincidence in numbers, and ask them to report every single word or phrase their dog reliably responded to. Not sort of responds to. Reliably. The dog had to look up, run, wag, whine, or perform a specific action tied to that exact word every time for it to count. The result. The average dog in their sample responded consistently to 89 words and phrases, not 165. 89. And there was real spread. The least responsive dogs in the study reacted to only 15 words. The most responsive dogs in the whole sample reacted to 215. Here's the detail that matters most for you personally. The single word every dog responded to, most reliably, wasn't a command at all. It was the dog's own name. After that came the basics. Sit, come, down, stay, wait, no, leave it, okay, and then food and play words. Treat, breakfast, dinner, ball, squirrel. Notice the pattern in that list. It's almost entirely words tied to an action your dog performs, or an outcome your dog wants, not abstract nouns, not descriptions. Trigger. That pattern is your first clue that something other than understanding English is going on. We'll come back to exactly what that something is. But first, let's go meet the dog who makes 89 look almost quaint. In Spartanburg, South Carolina, a retired psychology professor named John Pilley brought home an 8-week-old Border Collie puppy in 2004 and named her Chaser. Pilley had spent his career studying learning and behavior, and he had a very specific hunch that the reason most dogs seem to have a small vocabulary wasn't a hard ceiling on canine cognition. It was that nobody had ever actually tried to teach a dog a large one, systematically, the way you'd teach a child. So he tested it. For roughly 4 to 5 hours a day, for 3 years, Pilley taught Chaser the names of individual objects, mostly toys collected from secondhand shops. His method: say the object's name out loud more than 40 times while Chaser interacted with it, then hide it among other objects and ask her to find that one, by name, out of a pile. By the end of that 3-year stretch, Chaser could correctly retrieve 1,022 different named objects by name alone. And this wasn't a fuzzy, seems pretty smart result. It was tested formally, over and over, and in every one of those tests across all 3 years, Chaser scored 18, 19, or 20 correct out of 20. The research was published in 2011 in the journal Behavioural Processes, and one detail from that paper is worth sitting with. The researchers didn't stop training Chaser because she hit a limit. They stopped because they ran out of time and objects to test with. Chaser's actual ceiling was never found. Now, here's where it gets more interesting than smart dog learns a lot of nouns. Chaser didn't just memorize 1,022 individual labels the way you might memorize a phone number. She also learned to sort those objects into categories she could correctly respond to instructions using the general words toy, ball, or frisbee as a category label, separate from each object's individual proper name. And she demonstrated something called fast mapping, shown a group of familiar named objects plus one new, unnamed object, and asked to fetch an item using a word she'd never heard before. She would correctly go for the new object, inferring, essentially by process of elimination, that the new word must belong to the only thing in the pile that didn't already have a name. That's the same trick toddlers use to explode their vocabulary around age 2. So take a breath and hold both numbers in your head at once. 89 words. The average dog, reported by real owners, peer-reviewed. 1,022. One dog, with a retired cognition researcher running a structured curriculum on her 4 to 5 hours a day for 3 straight years. That is not a small gap. That's more than an 11x difference. And it raises the actual question this video exists to answer. What, precisely, is the difference between those two dogs? Is Chaser a different kind of mind, or is she proof of what an ordinary dog's mind can do when somebody actually tries? To answer that, we need to leave behavior for a minute and go look directly at a dog's brain while it listens to a word, which is exactly what a team, led by Attila Andics, at Eötvös Loránd University in Budapest, did in 2016. Here's the setup. The researchers trained 13 dogs to lie completely still, fully awake, inside an MRI scanner. No sedation, no restraints, just patient training, the same way you'd train a dog to hold a stay. Then they played the dogs' recordings of their own trainers' voices, saying different combinations of words and tone. Sometimes a genuine praise word like good or clever said in a warm, praising tone. Sometimes that same praise word said completely flat, no enthusiasm at all. Sometimes a neutral, meaningless word, the kind of word that carries no reward association, said in that same warm, praising tone. And sometimes a neutral word said flatly. 4 combinations, word and tone, crossed against each other, so the researchers could isolate exactly what the brain was reacting to. While all of this played, an MRI scanner recorded which parts of each dog's brain lit up, and the results map almost exactly onto how a human brain processes speech. When dogs heard actual words regardless of tone, activity spiked in the left hemisphere of the brain, the side associated with processing distinct, meaningful sound patterns. When dogs heard the intonation, the emotional shape and pitch of how something was said, that activated a different region, largely in the right hemisphere, independent of which specific word was used. Left brain for what was said, right brain for how it was said, processed separately. That's not a metaphor, that's what the scanner showed. And it's structurally the same division of labor your own brain uses to process speech. But here's the finding that actually explains your dog's behavior on the couch. The researchers also tracked activity in the dog's reward center, the brain region tied to pleasure and motivation. And the reward center did not light up just because the dog heard a nice tone of voice. It did not light up just because the dog heard a word it recognized. It lit up at its strongest only when both matched a genuine praise word, said in a genuine praising tone at the same time. Think about what that actually means for the sit in a happy voice experiment from the top of this video. If you say a genuine command word in a flat, bored tone, the left hemisphere word recognition system still fires. Your dog's brain does register that it heard sit, but the reward and motivation system doesn't get the same full charge because the tone half of the equation is missing. And if you say something completely meaningless in an excited, praising voice, the neurologist confirmed the diagnosis. The right hemisphere tone system lights up, your dog picks up on your excitement, and it may well get excited too. But that's an emotional contagion response to your tone, not comprehension of your sentence. Two completely different brain events, both capable of producing dog gets excited, and from the couch, you'd never be able to tell them apart just by watching. This is the mechanism the words your dog understands videos never show you. It's also the mechanism that explains why 89 is a realistic average, and 1022 to be your genuine outlier, rather than two numbers measuring completely different things. Every dog's brain has both systems, a word recognition track and a tone recognition track, running in parallel, feeding into the same reward system. What separates an 8-9 word dog from a 1022 word dog isn't a different brain architecture. It's how much structured, repeated, individually labeled input that word recognition track has ever actually received. Now let's get to the part most content about smart dogs skips entirely, because it's less flattering and more interesting. What Chaser did and what your dog does with its 89 words is genuinely impressive, and it is still not the same thing as human language. Here's the honest distinction. What both Chaser and your average dog are demonstrably doing is associative, referential learning, linking an arbitrary sound to a specific object, action, or outcome, strongly enough to act on it reliably, and in Chaser's case, even generalizing that link into categories and inferring new links by exclusion. That's real. That's not a trick, and it's not just a conditioned reflex in the crude sense. Fast mapping in particular is a genuinely sophisticated cognitive move. What's never been demonstrated, not in Chaser, not in any dog studied so far, is syntax. Grammar. The ability to understand that word order changes meaning. The way the dog bit the man and the man bit the dog mean opposite things to you, using the exact same three words. Every demonstrated case of canine word learning, including Chaser's 1022 objects, is about individual labels and simple two-part instructions, not sentence structure, not tense, not the recursive, rule-based system linguists mean when they say language. Chaser could fetch the blue ball, but there's no published evidence any dog understands why. The ball is blue, and blue is. The ball would strike a human as different. So here's the honestly stated version, the one that respects both the science and your dog. Your dog is not decoding your sentences the way a 2-year-old eventually decodes theirs. It is running an extremely capable, extremely fast pattern matching system, sound in, association out, reward checked by two separate brain regions working in parallel, and for a small number of extraordinary dogs with the right training, that system can hold well over 1,000 individual associations. That's not a lesser story than my dog speaks English. It's a stranger, more interesting one. An animal running a completely different kind of machinery and still landing, functionally, in almost the same place. And there's a coda to Chaser's story worth knowing. Her trainer, John Pilley, passed away in 2018. Chaser lived on with his family for another year and died in July 2019 at 15 years old, having spent essentially her entire life inside what was, functionally, the largest structured vocabulary experiment ever run on a single dog. Nobody has replicated that scale since, mostly because almost nobody has 4 to 5 hours a day for 3 years to give a dog the way Pilley did. which means the honest headline isn't "Dogs can learn 1,022 words." It's "We don't actually know the ceiling," because almost no one has ever tested for it. Here's a fair question, and a fair objection to raise about a single dog study. Is Chaser a genuine window into what dogs can do? Or is she a 1 in a billion fluke, the canine equivalent of a lottery winner, telling you nothing useful about the species? The honest answer sits in the middle, and it matters. Chaser is the most extreme documented case, but she's not literally the only one. Researchers studying what they call gifted word learner dogs, animals that pick up new object names unusually fast, without the kind of intensive, structured drilling Pilley used, have identified dozens of them since, mostly clustered in working and herding breeds, though not exclusively. They show up on multiple continents, in ordinary households, without a psychology professor running a curriculum. Most of them plateau well under Chaser's number, dozens or low hundreds of object names, not over 1,000, but they demonstrate the same core trick: fast mapping, inferring an unfamiliar word by process of elimination, the same move a toddler makes. So Chaser isn't proof that every dog is secretly a genius being held back by a lack of training. She's proof of something narrower and, honestly, more useful: that the capacity for large-scale, structured word learning exists in ordinary dogs, at meaningfully different levels from one individual to the next, and that almost nobody ever finds out where their own dog's ceiling actually sits, because almost nobody runs the test. So let's reframe the whole question, because how many words does my dog understand was never really the most useful thing to ask. Go back to that number line: 15, 89, 215, and then Chaser's 1,022, floating way off to the right. It's tempting to read that as a simple intelligence ranking: smarter dogs know more words, less clever dogs know fewer. But the Andics brain scan data tells you that's the wrong axis entirely. Every dog in that fMRI study had the same basic hardware: a left hemisphere word processing track, a right hemisphere tone track, and a reward system that lights up brightest when both align. Chaser didn't get a better brain. She got roughly 1,000 times more structured, individually labeled repetition than the typical pet dog ever receives. That reframes vocabulary size from a fixed trait into something closer to a training investment, which is actually good news, because it means the real, honest answer to "how much does my dog understand" isn't fixed by genetics, and it isn't something you passively find out. It's something you can actually go test tonight, deliberately, the same way Pilley did with Chaser, just at a smaller scale. And it reframes something else, too: the emotional side of this, which is the part a lot of owners quietly worry about. If your dog only reliably knows 40 or 50 words, instead of 165, that doesn't mean your dog is behind, or less bonded to you, or missing something a smarter dog has. The Reeve Jacques data already tells you 89 is just an average. Plenty of well-loved, perfectly typical dogs land under that, and plenty land over it, and none of that number is a referendum on the relationship. What predicts vocabulary size in that data isn't affection. It's consistent, repeated, meaningful exposure, which, conveniently, is also mostly a function of how much structured time gets put in, not how much a dog is loved. There's one more layer worth naming, honestly, because it's the part that separates PetMindLabs from the proven by experts videos. Word count isn't even really the full measure of comprehension. Andics data shows your dog is running 2 channels at once: words and tone, and for most of the words a typical dog knows, tone is doing a huge share of the work. Say walk in a flat monotone while looking at your phone, and plenty of dogs won't react at all. Say a completely made-up nonsense word zibberflop in the exact tone you use before a walk, and you'll get tail wags and door checking anyway. Neither of those proves your dog doesn't know the word walk. It proves that, in daily life, meaning and tone are almost never cleanly separated, which is exactly why so many owners overestimate or underestimate what their dog actually understands. Most of us are testing an entangled signal and reading it as if it were a pure one. So the real reframe is this: stop asking "how smart is my dog" as if there's a single number waiting to be revealed. Start asking a more useful, more testable question: how much of what my dog responds to is the word itself, versus how I say it, and how would I actually find out? There's a broader version of this reframe too, and it's worth sitting with for a second. We tend to ask, how intelligent is this animal? As if intelligence were a single dial, running from just instinct up to, basically, human. The word versus tone split makes that dial look like the wrong tool entirely. A dog's brain isn't a dimmer switch on the way to being a small, furry human brain. It's a different configuration built to solve a different problem. Not understand abstract concepts, but extract, as fast and as reliably as possible, what a specific human wants right now from the sounds and tone that human happens to be making. Judged against that problem, not against grammar, not against sentence structure, the system is remarkably good. Chaser didn't need syntax to hit 1,022 correct retrievals in a row. She needed a reliable sound-to-object mapping and a way to generalize it, and she had both in spades. That's really the difference between the 165 words, proven by experts' videos, and what you just watched. Those videos are quietly still asking the human language question, is your dog basically speaking English yet, and grading dogs against a test they were never built to take. The actual research asks a better question, gets a stranger and more precise answer, and, if you ask me, ends up with a lot more respect for what's happening in that skull next to you on the couch. Let's make this something you can actually run tonight, a simplified, safe, at-home version of exactly what separated Chaser from an average dog: structure, consistency, and a real test. Before you teach anything new, find out what your dog already reliably knows using the same standard Reeve and Jacques used in their study. A word only counts if your dog performs a specific, consistent action every time it hears it, regardless of your tone or body language. Say the word flatly, without your usual excited voice, without your usual hand gesture, and see what survives. You'll probably find your dog's real, tone-independent vocabulary is smaller than you assumed, and that's not bad news. It's your accurate starting line. Pick one command your dog knows well. Sit is easiest. Say it in 3 different ways on 3 different days. Your normal warm tone, a flat monotone, and an oddly stern tone. If your dog sits reliably across all 3, that word has genuinely crossed into the left hemisphere, word recognition track for your dog, real comprehension of that specific label, not just a mood red. If your dog only responds to the warm version, you've just directly observed the Andics mechanism in your own living room. The tone channel is doing most of the work, and the word itself hasn't fully landed yet. You don't need 4 hours a day. Pick one object your dog doesn't have a name for, yet a specific toy, not a category like toy. Say its name clearly every time your dog interacts with it, for a few minutes a day. For about a week, Pilley's method was over 40 repetitions before testing. Then place it among 2 or 3 familiar objects and ask for it by name alone. No pointing, no looking at it yourself. This is the exact structure behind the 1,022 object study, just compressed to a scale you can actually sustain. Once your dog has 3 or 4 solid object names, try this. Put those familiar objects in a pile along with one brand new object it has never seen or heard named. Ask for the new object using a brand new word it's never heard, something you invent on the spot. If your dog goes for the new object rather than one of the familiar ones, you've just replicated, in miniature, the exact fast mapping result from the Chaser study. Inferring a new word belongs to the only unnamed thing in the group. Not every dog will do this. Many won't, especially without a strong existing base of labeled objects. But it's a genuinely fair, fun test to run, and if it works, you've just watched real inferential reasoning happen in your living room. Because you now know the actual mechanism, use it kindly. Don't assume a flat no carries the same weight as an urgent one tone. Genuinely changes how strongly the message lands, so match your tone to how much you need the message to register. Keep instructions to single, clear words, or short 2 to 3 word phrases, rather than full sentences, off, not, please get off the couch right now, because you're working with a system built for labels and short cues, not syntax. And when your dog gets something wrong, remember what the brain scan actually showed. It isn't ignoring you out of stubbornness. It's running a real, sophisticated, but fundamentally different kind of language system than yours, one built on sound-to-outcome mapping, not grammar. Meeting it there, instead of expecting it to meet you in English, is where the actual respect is. If you want to actually grow your dog's real, tone-independent vocabulary rather than just guessing at it, treat it like the small, structured project it actually is, instead of something that either happens automatically or doesn't happen at all. Pick exactly one new word. Use it in the exact same flat, clear tone every single time for the first week, specifically so you're training the word recognition track and not just the tone recognition track. Only once your dog responds to the flat version do you get to reward it with your normal warm voice and affection that ordering matters, because it's the difference between teaching a label and teaching an emotional cue. Most owners who feel like, my dog only knows 5 things, have never actually run a deliberate single-word teaching block like this. They've only ever taught commands buried inside excited, high-energy moments, which teaches tone reading beautifully and word recognition only by accident. A single clean week, one word. Flat tone first, and you'll likely find your dog's real vocabulary is more elastic than either of you assumed. Here's what I keep coming back to. For a long time, the honest answer to, "Does my dog understand me?" got flattened into a yes or no question. And both easy answers were a little bit wrong. No, it's just tricks, ignores fast mapping, category learning, and 1,022 individually remembered names. Yes, it understands everything I say. Ignores that no dog studied has ever shown. It understands grammar, and that half of what feels like understanding is really your dog reading your tone, not your words. The true answer is stranger and, honestly, more moving than either of those. Your dog is running a real associative language system, one that lit up on a brain scanner in a pattern strikingly similar to your own, splitting words from tone, rewarding you most when the two align. Most dogs run that system on a modest, perfectly respectable vocabulary of somewhere around 89 words. One dog, given years of somebody's full attention, ran it all the way to 1,022, and even then, nobody ever found where it stopped. So tonight, when you talk to your dog, really talk. Not just command. You're not talking to something that's faking comprehension, and you're not talking to something that speaks English. You're talking to an animal running its own real, measurable, specific kind of language, built from thousands of years of paying closer attention to your voice than almost any other species on Earth ever has. That's not a smaller thing than language. It might be a rarer one. If this changed how you talk to your dog, do me a favor. Tonight, try the flat tone test from this video. Say one command with zero excitement in your voice, and tell me in the comments what happened. No wrong answer. I just want to know what you found. If you want more of the real research behind what's actually happening in your dog's head, subscribe, because that's the whole reason PetMindLabs exists. We turn the actual science of dog behavior into something you can go test on your own living room floor tonight. Next time, we're staying with the tale what the direction and speed of a wag actually tells you, and why happy is only half the story. I'm glad you're here. This is PetMindLabs. Stop guessing. Start seeing.